Good morning and welcome to this Friday, where we are wrapping up our discussion on divisibility. It's nice to see that so many people show up whenever there is no new lecture and we're just practicing questions. Just means everyone has mastered the material. It's awesome. It's always good to see. We are today going to do a couple of exercises just to double check if we are comfortable with knowing and using the different divisibility tests. So I'm not going to put these on the screen. I'll just copy them. I'll put them on my other screen so that I don't make mistakes. We are doing exercise 9.4 and we want to determine whether or not the following number, which is big, I'm going to call it n. So I don't have to write all these digits every single time if that is divisible by all the numbers we have a test for. So let's start. So we want to know divisible by 2. So then I have to remember the test for 2. And that test says check the last digit. If it is 0, 2, 4, 6, 8, I'm good. So it's a yes. Reason, you have to say yes or no, divisible, yes or no. And the reason is the last digit is an 8. So you have to remember to give the reason. Don't just say yes or no. That's only half the answer. Next up, we're just going to go in order. Is the number divisible by 3? 3. Well, for that, I need my comparison number. It's going to be 5 plus 7 plus 5 plus 9 plus 7 plus 1 plus 4 plus 7 plus 2 plus 8. I hopefully didn't miss any digit. Add up the digits. Ooh, what do we get? We get 12, 17, 26, 33, 34, 38, 45, 47. It looks like 55, if I did that right. And therefore, it is an unfortunate no, because reason 3 doesn't divide into 55. All right. So you have to say yes or no, and you have to give the reason so that I can confirm that you understand the divisibility tests and you didn't just use your calculator. We have to be able to assess that you've used the divisibility tests. Divisible by 4. Well, I can call it my comparison number. Is the number formed with the last 2 digits? 28. And 4 divides into 28. So, yes, the whole original long number will be divisible by 4 as well. Next up, divisible by 5. That'll be a no. Let's call it my comparison number. Comparison number is the last digit. It is an 8, which is not a 0 or a 5. And so I keep going. Feel free to interrupt if you have any questions. You came all this way. You are free to ask questions. Get the benefit of a live session. Divisible by 6. I know that my test requires that it has to be divisible by both 2 and 3. And if I look up at the top, I see 2 was a yes, but 3 was a no. Therefore, 6 is a no. Reason, it's not divisible by 3. I need both. So you have to say yes or no and a little reason, demonstrating that you understand the test. You can say more, of course. The more words you write here for your reason, the better the better it is, the easier it is to mark. I always like when people write a lot of sentences explaining themselves very clearly. Oh, excuse me. It's so much easier to grade. I get so emotional about words and explanation. So beautiful. But it does make my life very easy, and there's no doubt that you know what you're talking about when you're able to use a lot of words. We, of course, skip 7 because 7. And next up is 8. I have to have my comparison number, which in this case is the last 3 digits, 728. And then I can see, well, 8 divides into 728. How do I know? Because I do a quick long division in my head. 8 goes into 72 9 times with no remainder. 8 left, 8 goes into 8. There's not going to be any remainder. I don't care what the answer to the division is. I'm just interested in, is there a remainder or not? And then divisibility by 9. For that, I have my comparison number again, sum of the digits, which is 55. I hope that's correct. No one says otherwise. And 9 does not go into 55, right? 9 doesn't like 55. 54 would have been good, but it is not what I have. Last two, divisibility by 10. Well, clearly not, because my comparison number is the last digit, which is an 8, and that is not a 0, which is what it needs to be. Then lastly, divisibility by 11. Don't let me go too fast. Feel free to interrupt me at any stage. My comparison number that I have to check. Well, let's go up. I remember that starting from right to left, I have a plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. So let's set that up. Oopsie. I want to make it clear here that I understand what to do. 8 minus 2 plus 7 minus 4 plus 1 minus 7 plus 9 minus 5 plus 7 minus 5. Did I do that right? Yes. Okay. 8 minus 2 is 6. Then I have 13. Then I have a 9. Then I have a 10. Then I have a 3, 12, 7, 14, 9 it looks like. And 11 does not divide into 9. So that is a no. Unfortunately not. So I don't want to say, oh, my comparison number is 9. I want to explain a little bit. I should do more here. You're right, I'm lazy. Last digit is 8. That's the number I use to make my decision. I'll call it the comparison number. Because it's not a 0, my answer is a no. So comparison number is this alternating sum. Getting a 9, 11 doesn't divide into 9, and therefore my conclusion is a no for the original number as well. Okay. So there we went through all the divisibility tests. You decide what you need to do to know them all very efficiently. Now you don't know which divisibility I'll ask in a test, maybe a couple, maybe just one. So I want to be ready for all of them. All right, exercise 9.5. I like this kind of question. It's a little more fun. Let's show it. Determine the missing digits in the following numbers so that it satisfies the divisibility requirement. So in the first one, I have a missing digit there. It's 70 something 434, and all I know is it has to be divisible by 9. What is the missing digit? All right. Now, there's probably more than one way to do this. Let me set this up first. 7 something 434 divisible by 9. Now, of course, you can go the plug and play method and say, okay, put in a 0, put it into my calculator, divide by 9, see if I get a decimal number. Or with decimals, yes or no. Put in a 1, try that. Put in a 2, try that. Put in a 3, try that. I am not interested. This seems silly. It would work, absolutely. But is this really the intelligent way to do it? No, of course not. So what I'm going to do is I'm going to call this digit, call it x. Call it whatever you want. Just some symbol to keep track of that digit. Because now I know the divisibility test for 9 requires that I look at the sum of the digits as my comparison number. Sum of the digits. And that's going to be 7 plus this mystery digit plus 4 plus 3 plus 4. What do I get? I get the mystery digit plus 11, and another 3 is 14, 18. So this must be divisible by 9 if the original number is divisible by 9, which it is. So now I have much fewer options for x. So my possible values of x are 0, because then the comparison number would be 18, which is good with 9. But I can also use a 9, getting me up to 27, which is also divisible by 9, and that is it. What's this line doing here? So if I know what the divisibility tests are, I can go much faster than plugging in each possible digit without any thinking involved. That's not what we want to do. Though, I guess nothing stops you from doing that because the question didn't specifically say, but if you want to be inefficient, that's up to you. I want to be quick, move on with my life to questions that actually require my time in a test. So that's how we're going to handle it. And of course, it depends on the number in question. The next one is 436 something 86, and it's divisible by 8. Now, the divisibility test for 8 is a completely different story and might require a different approach. In the case for 8, 8 is probably the worst one. It's not, yes, it is faster than looking at the whole big number, but it's not as fast as adding up the digits or looking at a last digit or last couple of digits. Looking at the last 3 is still slowing me down a little bit. Even if I call it something, call it x, then my comparison number is x 8 something 186. It's still not going to be super fast. There's some trial and error here. At least I don't have to look at the whole thing, try 0 and so on and so on and so on, do the division. There's still some intelligence behind this, but it's not as fast as I would like. I am going to try. I am going to have to think about 0, 1, 2, 3, all the way to 9. I do have to run through the options. I can do it very quickly and stop me if you're not comfortable with any part of that as I go, because I can do a 3-digit division in my head quickly. But I am doing the long division just really fast. If I use a 0, I'll do the first one. I picture this 8 divided into 0.86, or just 86. I do this in my head. I picture this. But there's not a lot of digits I need to keep track of, so it's okay to do quickly. So 8 goes into 80 with no remainder. I don't even care how much, just no remainder. And not 6, so that's a no. There's a remainder. That's all I care about. I don't care what the answer is. I don't even keep track of that. I just keep track of the remainder every time to see if there is something left at the end or not. So I'll do one more. So I do picture that in my head, and then I picture the next one, but I can do them very quickly. 8 goes into 18 with 2 left. The 2 goes here. So 26 left, that's a no. See, it's not even a full division. I just keep track of what's left. As I go through the digits left to right, if there's something left at the end, then it's a no. So I can check 286. 8 goes into 28. I'll talk through it so you have some reference. 8 goes into 28 with 4 left. It's really 40, right? 46? No, it doesn't like 46. So they're all bad so far. I should probably list them all then if I'm going to do it like this. So uh, it's it's going to seem slow because I'm writing a little bit more and talking through it a little bit more. It is a little slower than the others because of 8, but it can still be done fairly quickly. 386, I'm looking at 38. 8 goes into 38 with 6 left, right? 32. 66, no. It's going to be something left. I don't care what it is. I just need to know if there's something left. 486. 8 goes into 48, yes, but then there's 6 left. Nope. 586. 8 goes into 58 with 2 left. 26 is a no. 686. 8 goes into 68 with 4 left. 46 again, no. 786. 8 goes into 78 with 6 left. Wow, we get a lot of 66s. It's all bad times. 888 is not going to work because 8 goes into 88 and then there's a 6 left. 986, maybe one of them is going to work. The last option is a 9. 8 goes into 98 with 2 left. 26 is a no. Now this is the worst case that you have to do. So there are different levels. I'm doing this on purpose. There are different levels here. The very bottom level, with as little thinking as possible, is going to the original number, plugging in each possible digit into your calculator, dividing by 8, seeing the answer if there are decimals or not. That's going to work. I have a calculator. If you put down the calculator, which I hope you do, I have to be a little bit more intelligent. This is the next little more intelligent step using the divisibility test for 8, but still there's some thinking through all the possibilities required. Or we can look at multiples of 8. This doesn't always work, which is why I didn't want to do that from the start. Multiples, of 8. Of 8. I have 8, I have 16, I have 24, 32, 40, 48. I'll do a couple. 56, 64, 72, Let's do one more. 80. Now look at the pattern here because there is one. The ones digit. 8, 6, 4, 2, 0. 8, 6, 4, 2, 0. And the next one's going to be 88. The ones digits loop around every 5 multiples. It cycles back and starts with an 8 again. Not the other digits. Of course, they get bigger and bigger and bigger. But the ones digits loop around. 86420. It's actually a nice pattern. Which means that regardless of the test for 8, if my original number doesn't end in one of these ones digits, 8, 6, 4, 2, or 0, that number can never be a multiple. Because this number has to be in some loop later on as I make my list of multiples. Sometimes I can be fast like that. I say, I don't even care about the test. If this number, for example, just temporarily, if this number ended in a 5, I don't even have to test the divisibility or use the divisibility test for 8. This will never be a multiple of 8, looking at the pattern of ones digits in the list of multiples. But unfortunately, in this case, it does end in a 6, so there is a chance that this number could appear in a loop later on. So then I have to go and dig a little deeper. So there are different levels, properties, little things. I have to be careful because my knowledge is limited. I don't want to see things where there aren't things, really. So we try and keep things in check. But focusing on the ones digit, at least, often I can do this, and my list of multiples will only have a certain collection of ones digits. If my original number doesn't have that, then regardless of the divisibility test, I can go even faster and say it cannot be in this list. But don't look at too much of the digits. It gets a little complicated. But you can look at the ones digit as well. So that's an extra tool that I can have. That doesn't always work, which is why it's not classified as a divisibility test, because just because the number ends in a 6 in this case, for example, doesn't mean it is in this list. So it only goes one way. If it doesn't end in an 8, 6, 4, 2, or 0, then it's definitely not divisible by 8. But just if it does, that doesn't mean it is divisible. So that can be confusing for people. It's only one direction requirement or property. The divisibility tests work in both directions. So use with caution, but there are other things that one can exploit. Number 3. 6397 something 8 divisible by 6. Now I can do a little check for the ones digit, but 48 is a multiple, so a number can definitely end in an 8. There's not much I can say further. So I need to use the divisibility test for 6, but it's super easy. All right? This number is already divisible by 2. Ooh, that is an ugly 2. By 2? Yes. So my only real question to answer the original is the number divisible by 3? So for that, I'm going to call the digit x, and my comparison oops, number is going to be the sum of the digits. Oh, no, come on. It is a 9 and a 7 and an x and an 8. And so I get 9, 18, 25, 33 plus x. For that to be divisible by 3, the possible values of x will be 0 to get me 33, 3, 6, and 9. And that is that. So sometimes I have just one option. Sometimes I have more than one option for the digits. Sometimes I have no options that could possibly work. It depends. I have to find all the digits that would work. All right, we have two more. Number 4, 7 something to 8, divisible by 11. So let's call it x, just so I have the ability to reference it. My comparison number is going to be 8 minus 2 plus x minus 7. So I get x minus 1. This has to be divisible by 11, and x is a single digit number. So it's not hard to see my possible values of x can only be 1. I need to get to 11, 0, or negative 11 with a one-digit number here, subtracting 1. It's either have to be 12, which is not going to work. 1 minus 1 is going to give me 0, or negative 11 is going to require that to be a 10, which is not a single digit. So 1 is my only option. Because as we saw, a 0 answer for my comparison number is also going to be a good thing. And then one more to do. 2, 2, 8, 7 blank is divisible by 4. All right. Oopsie. So let's call it something if you want to. Call it x. Sure. My comparison number is 70 something. I put a line under it, making it clear that it's not a variable in the conventional sense. It's a place in the decimal number. 70 something. And that has to be divisible by 4. But that narrows it down significantly. And I can right away say my possible values of x will be 2, 72 is divisible by 4, 76 is divisible by 4, and that is going to be it. Because I know my multiples of 4. Or I can very quickly do a 2-digit division. And that is that. That is that. We've practiced some divisibility questions. We have some more problems that you can work on if you want to, but based on the attendance, it seems like people have mastered this pretty easily. In the remaining time, feel free to ask me questions, but we are done pretty much. I'm not going to do exercise 9.6 for 7 because 7 doesn't deserve it. He doesn't give me a nice divisibility test. Let's quickly look at the problems. These problems are really, really good tests to see if you really understand what's happening here, especially something like 9.1, 9.2, 9.3. They're all good. More tests for divisibility, smallish numbers. 9.5 is nice. People underestimate that one. You can practice some long division in 9.6. 9.7 is like our exercise. 9.8, if you don't like the general statements here, you don't have to worry about them because we're not getting tested on that. And then 9.9 and 9.10 are similar to the last exercise we did. So have a look at those if you feel like it, or if you don't, whatever you like to do to make sure you master this topic. The last thing is, please note the schedule. What is happening on Monday is a video session where you watch a video on the next chapter on your own pace, at your own pace, your own time. And then, of course, you can let me know if there are any questions. I will hang around if you have any questions, but uh, that will be the end of the live session on video.
Sounds good. Thank you.